Have you ever worked on a scalable product where you face different performance related challenges in different contexts of the product, be it the user growth or the services that you are offering? So both of them are scaling and your application is getting impacted. This is one of the challenge which one of the company that faced, which is into the OTT and streaming platform domain. The company name is Disney Hotstar. They work on the OTT and streaming services. They faced a challenge like the one I was explaining earlier, and they solved it as well with their engineering capability. We're going to discuss that in some time, but this is one of the challenge, or these are some of the challenges which the global companies usually face, where the engineers come out victorious in some of the scenarios by applying their algorithms, by applying their great minds as well. Hi guys, so today we are back with a new video. So today's video is a bit different. Today's video is about a use case where we're going to talk about a real company like Disney Hotstar, where what kind of challenges they faced and how they fixed it. They faced different set of challenges while they were working on their product. We're going to discuss about initially one or two challenges in this video and some of the challenges in the next video. So let's discuss about first about their architecture, how it usually look like for a layman. The architecture that we're gonna first look at, this is pretty simple for a basic application, and they started with the same as well. But I'll explain you the problem statement that they first addressed and how they went into step by step to another problem statement and solving them as well. So let's look at this diagram very carefully. So in this diagram, I have created a basic microservices based structure, which is inherently using EKS, Amazon Service, Amazon VPC, and some of the architecture components that are being used in this application. Clients, CDNs, application load balancers, gateways, and services. So these are the normal architecture components that we usually see in most of the applications. Apart from this, we have the AWS managed databases also, and the main part is the AWS VPC and the EKS. The story, how it started, it revolves around the scale. It revolves around the user growth. Now, as you all might know, in last few years, there have been a high voltage cricket matches of Indian women's and Indian men's cricket team as well. All those matches were getting streamed on Hotstar platform in last few years. They saw a huge growth in such matches, and in such a in such one of the matches they faced challenges to scale their product and bring more users on the platform because their platform was not scalable enough to cater to the demands of the growing users. That's where they identified the bottlenecks in their architecture. Now, if we look at the architecture, the clients are nothing but your mobile applications, websites, or anything, something like that. They interact with the CDN, and then there is a component called Route 53, which is not in this architecture, based on which it finds out the domains of the services or the gateways. ALBs, these are nothing but the application load balancers, which are a kind of internal or not internal, I would say, but the internet facing kind of load balancer. CDN, as we all know, so it basically delivers you faster streaming on the edge networks. And at the same time, application load balancer redirects the request to the internal gateway, which is into the EKS cluster. And internal gateway basically routes the request to different internal services present inside the cluster. And then obviously the services talk to the managed databases also. Now, first challenge they faced is they were not able to identify where is the bottleneck. Now, how to identify in such a huge services based architecture? Now, they had plethora of services. I don't know the exact number of services, but they may have around 100 to 200 services at least, or maybe lesser than that. But each of the services required a huge number of containerization to scale to demand to cater to the demand of the users. In this, how they identified which are the services which are the problem creating. So there were different services which were taking more load, and some of the services were taking less load were placed in the same cluster when they were creating an architecture. Now what they did is they try and understand how does the AWS VPC flow logs are going from different subnets. So they had this EKS cluster created in different subnets, and that's how they identified the flow logs from where the traffic is going and which all services are consuming or calling more externally to fetch the data. Now, why I'm talking about externally? Now, in this application, which we are talking about the scale, the matches used to happen in the night, and the users, as India is a cricket loving country, so there used to be a huge traffic on the OTT application to watch the match. Now, the match score doesn't come directly into Hotstar system. Hotstar has to poll the scores every second or whatever, and there is not only the scores but other things also like the ads or any other services that Hotstar wants to offer on the while the match is going on. So to deliver the match and at the same time deliver the content, let's say you are streaming a match. While you are streaming and at the same time you have to fetch the latest scores also while you are streaming, while you have to display the scores on, let's say, any of the widgets. So there are different services that talks externally as well. Like one is the video streaming. It has to be streamed on your architecture so that you can watch the match quite real time. We are not going ahead and gonna talk about the video streaming architecture here in this video. That we can leave it out to some other day. But now we're gonna focus on a different problem where some of their services were talking outside for fetching the external data like scores, ads, and all that, because that also have to be shown real time in comparison to how the match streaming is happening. Because as you may have seen, in some cases the ads comes in between while the match is going on as well, so there they have to pull the ads also externally. So that's why their services were talking outside from some external services to fetch that data. That's where they had analyzed that some of the services are having huge outside traffic. They had to segregate those out and put them in a separate cluster or subnet or whatever. So then they decided to come up with separate, they already had separate subnets, and they already had, I would say, different services categorized. But now they wanted to restructure where their services are getting placed. Earlier, their services were placed, let's say, in one of the small clusters, or let's say all the services in one was in one cluster. Now they segregated out those clusters, and at the same time, they segregated out the subnets also. So we will talk about the subnets also in few seconds for a short span of time. Now, the subnets, when their services are talking outside. Now, let's say I have this one subnet, I have this one subnet, this both the subnets are in one cluster. So now what happens is their services has to talk outside. They will talk outside while they are in subnet via a NAT gateway. Earlier, what used to happen is their uh, most of their services were present in one subnet, and their traffic on the NAT gateway was getting huge as well. That's where they had to decide that which services they have to keep in which subnet so that the traffic on the NAT gateway is also reduced as well. So this was the another problem that they had to solve after the understanding which are the services which are the problem creating ones and which are the services which we can place in one subnet so that they can utilize the NAT gateway efficiently as well. There was a role of AWS EKS. Maybe we'll discuss that in the next video as well. For now, we will keep our video short till this point of time. So these were some of the problem statements that they highlighted or that they faced. First was, I'll recap it for you. The first was how all the services which are present inside their network, how to scale them such that they are placed in such a way that they can scale frequently as well. This is the first problem. And second thing is how you can talk to external services or external APIs efficiently and get the required data, and at the same time stream also in near real time and scale also. Now, in this scenario, some of their services who were talking outside, those were present in a closed subnet together, because of which they were not able to efficiently, or I would say they were overutilizing NAT gateways capabilities. And we had to utilize NAT gateways more efficiently by re-platforming their architecture or by introducing more different subnets also. That was their another challenge that they had tried to solve. We'll discuss about this in more detail in our upcoming video also, and some other problems also they faced as well. So thanks a lot for watching the video. If you're liking the content, do like and share the channel and share the video as well. And do leave a comment what content you want to cover in the next upcoming videos as well. Thank you. Have a nice day.